So agentic pipelines sound great in theory, and you can always do really nice clean demos that make them look fantastic. But I've had a lot of comments asking me like, what does one of your pipelines look like in reality? So today I want to take a pipeline that I use almost on a daily basis and break it down for you step by step and walk you through the pros, the cons, what I'm still working on, and talk through what the sort of meat and potatoes of a pipeline actually is. Sorry for saying meat and potatoes. That was weird. All right, let's get started. Okay, so the goal for today's video is to break down like what one of my actual pipelines is that I'm using, break it down step by step. I have a whole section here on all the different steps and examples, stuff like that. What is this pipeline? This pipeline is basically one that I use anytime I'm adding pages to our settings. This is just the fun app that we've been working on, that I've been working on. And you can see there's actually some issues on it right now. And anytime you have settings, we basically have a pipeline designed to add settings pages. And what this pipeline does and why it exists is because we have a variety of different apps that are all basically built on a single SDK system. And that SDK system basically mounts different settings pages because you can share a lot of them. And so the theory being that we can make a much more efficient way of doing development. More on that to come maybe in the future someday. But generally speaking, when we're mounting settings pages, there's very specific headaches that it gets wrong. I want to show you an example of one, which is this. It just mounts the whole thing really weird into the app, into an app. It doesn't realize it's supposed to use basically one of the page archetypes. I don't know. Archetypes. Got there. That is like basically partial and designed for this. Yeah, so that's what I'm going to go through is this pipeline and explain it, right? The pipeline has 13 phases. You give it a prompt. It checks out its own branch and work tree, opens up its own session, does research, plans the work based on the research. Second agent reviews the plan, writes failing unit and API and end-to-end tests, implements all the tests, and then implements the code until the pass, and then refactor. And then this is your deterministic policies, which we'll get into, and so forth, right? And then all of the test automation. So yeah, goal is to do that. How that actually looks in code, you can see here I pulled the pipeline out into its own code base. So at its core, you have the pipeline as it's a TS file. If we scroll down, you should see the main function here. Yeah, main. So basically, this is super straightforward. It's just simply running main. And main is just an amalgamation of a bunch of functions, as well as things like here's how our ledger system works, or here's all the saved prompts for this pipeline. And it's going to work its way down all these functions, right? So you have your one research, run plan, so forth. I also apologize. I haven't really eaten today. So if that comes through in the video, give me feedback and I will remember to try to eat more often. Okay, so let's get into it. First step in the pipeline is kicking it off. So how do we kick off our pipelines? We basically run the function along with an argument that goes in with it, which is the prompt essentially of what you want the pipeline to do. So in this case, the pipeline would be mount a CLI session setting on the Wixer module. And here's all the other stuff, right? And so we're working in the app. Actually, in this case, that's out of date. I switched. I was going to do our simple CRM app, and now we're doing the newsletter app. And so what's actually changing basically is the sort of breakdown of the prompt, right? So very simple, straightforward thing. So your pipeline basically just needs to be able to accept arguments, right? That's step number one. Step number two, and this is important because when you're running a lot of these at once, it becomes a complete mess. We have every pipeline open its own branch and its own work tree. So basically the first stage of a pipeline is going to be that it checks out a branch and that it also creates its own work tree based on that branch. So the pipeline is running completely independently, and we can have 4 or 5 terminals running at any given time, and they're all just doing their own thing in their own branches, right? And then it creates its own session directory. So here's all your output with your session ID and so forth. So it's designed to do that. So that's step number 2 it does. So governance note, by the way, why it's really important you do output is because of governance. So we basically have this directory as a feed of what the pipeline actually did. So the pipeline is spitting out stuff as it's going that's required to do that. Anything from decisions to research to what prompts were used, etc., what responses were logged. And then when we have the tool that we have when it comes to the governance system, which I'll show that at some point. I think I've showed that in one video of trying to look at the output of the pipeline. It's just pulling this basically. It's a CLI tool that pushes this up into that desktop app, and then it pulls from this. Okay, continuing on. So this is your first step. You're actually asking the pipeline to do something, right? So read the existing architecture docs, map the existing phase. So this is where you start to have a lot of benefit in creating like bespoke pipelines, because there's a couple kind of core reasons why you want bespoke pipelines, right? Like one is you have different things, different aspects of the system struggle with, and you can have greater review loops, for that one area. And basically you can make sure that certain pipelines focus on certain areas in a lot more detail. And then the rest of it is that you can also feed in a bunch of context. Now, what I will also call out is like we have a handful of pipeline basically templates that are structurally the exact same, but just have different required reads and reference files and prompts and stuff like that. So you end up having this kind of balancing act when it comes to pipelines of what are these sort of 4 or 5 shapes of pipelines you use for a lot of the things, and then certain tasks that need a lot more work or maybe a lot less work, you end up with different shapes of pipelines with more or less review loops, etc., more planning steps, less planning steps, maybe more parallel quad code instances, stuff like that. But in this case, you could guess if this shape works for other pipelines, which I'm trying to remember if our settings pipeline is used for other things. I'll have to get back to you about that. You simply are just passing in like different data, right? So if we go back and we look, you can see that the prompts are all stored here, right? And that's separate than the actual pipeline. So that makes it very easy to, if you want to plug and play the pipeline, you can just pull it out all this stuff from lib. I also want to call out, because this pipeline doesn't do it, we have a decent number of pipelines that basically have parallelization built in. So Claude, as everyone knows, can do multiple agents, right? And like orchestration, which is great. Don't get me wrong. We use it all the time. That being said, we do find that there's a lot of benefit at times, both when it comes to limiting the context windows as well as the ability to tie feedback loops to the specific individual parallelized tasks, that it makes sense to do things in parallel. One of our other pipelines, basically at this step, what happens is you have someone who plans out the research, or not someone, something that plans out the research into like lanes, and then it basically spins up Claude Code instances for that. So like once again, going back to this, if we go and we find the actual piece, right? So you have it running, and so you have research, run research phase, and we can just F12 into that. And what does this actually look like? It is simply a function that takes in a prompt that then runs the Claude Code instance, and then it writes the event at the end, right? So very straightforward in that sense. And you can see, here's an example of it running in parallel. So run parallel, one prompt per planned step. Each agent gets a different scope, and then it basically will spin all of the agents up in parallel. Very important that you have a max number of parallel things that you want to run if you want your machine to not completely shut down on you. But running in parallel is a nice tool. It makes the whole thing a lot faster. This is a little note. A lot of our tests are also built in a way that you can write them all in parallel, but I don't think this one does that. I think this one's all sequential. I will note, so, and this goes back to, I think, one of the things that's worth sort of thinking about as you're going through this, that like with great power comes great responsibility. And just because you have all these things available doesn't mean you should do them. Like the art of a pipeline is making it as simple as possible with as few quad codes as possible to achieve the highest accuracy. And I'm actually going to learn that the hard way. Like a lot of our pipelines, I think, were over-architected in terms of the number of steps and how much was parallel and how much like optimization I was trying to do. And I was sitting there basically having more success with just a single Claude Code instance or Codex instance, which actually Codex is so much better than Claude right now. Codex instance, and being like, why am I doing all this pipeline stuff? And it's because at certain times it's unbelievably useful and critical, and oftentimes actually, and it comes with all the governance layers and stuff. But don't just do things in parallel because you can. Like it doesn't make sense. Okay. Plans are JSON. So I'm obsessed with the idea of trying to take non-deterministic AI and shove it through deterministic things. So when it comes to a development plan that is made by our pipelines, we force them into a JSON object that is a schema that is validated to make sure it has everything that the plan needs. So when it creates a plan, which if we go down to run plan phase right here, this is going to basically spit out a plan that is going to match this schema. And that way we can be a lot more confident in its ability to actually then implement that plan. And you also can see that this has a validator loop in here. So you have a validate plan. And sometimes our validator loops are deterministic in the sense of it's a, hey, go run this policy file or something like that. And then other times the validator loops, are more non-deterministic in the sense of it's, hey, here is a agent, like a manager agent, who is going to confirm the behavior before moving it on. All right, I reject the most expensive pen mistakes. Yep, so this goes back to here's an example of deterministic checks going in before it goes through and basically making sure that you have deterministic checks. Now, you could do these at the end too, but like it is really important if you generally know how the plans make mistakes consistently and like you want deterministic ways to basically catch it. Like once again, you can do some of this stuff with prompts and rules, but like it genuinely does need oftentimes deterministic. That being said, you should always have a second agent read the plan. So why do we have a second agent read the plan? We have found that generally when you have a new agent or new context, it is much better at critiquing work as opposed to critiquing its own work. And so what we always have is the second agent reading it and they have a decision, either approved or feedback. And what that does is that creates up to 2 rounds of feedback. If it still can't get through, basically it shuts down the whole pipeline. And actually, that's a different video I should think about because one of the headaches is making sure that you have the ability to start pipelines from midpoint failures as opposed to having to start them over just to save a bunch of tokens. Okay, so this is where it starts to get into our personal style. We tend to write most of our tests up front. So unit, API, and end-to-end. That is very different than a lot of organizations who oftentimes, even if they're doing TTD or just doing unit tests, we like having completely functional failing tests. It just frankly, we have found that at this point, AI is good enough to where if you have effective prompts and good product documentation that's being passed into the plans, which we can show you right all in here, like all your docs, then if you write failing tests, you are going to end up with an app that works. Now, what I will call out is it oftentimes is not perfectly styled. So you still do need to go in and oftentimes as a human go through and be like, how did it think that this styling thing made any sense? But functionally, it's going to get you to the point where the feature is built and then you can very much do some cleanup. So same thing, if we go back and we go down to our loop, we're now at the phases. And actually in this case, you can see it's different functions. So first create all your unit tests, make sure they're read, then all your API tests, and then all your end-to-end tests, right? Sometimes we will have a QA manager or something like that who's in charge of creating all the different test cases for the different levels to try to optimize like as having as few as possible end-to-end, some API and some unit, but on a case-by-case basis. How are we doing on time? Okay, we're at 13 minutes. So I'm going to try to get through the rest of this fairly quickly. You can see the function right here and then the prompt. So write failing unit tests at case discipline. Yeah, okay, so that's tests. Great. And then I think this is out of order. I don't think we do static analysis at this point in this pipeline because I think we do it as the policy point, the policy gate, which is after the greens. So we're going to skip the static analysis component of this and we'll keep going down. We'll come back to it possibly. All right, here's your build loop, run green phase. So this one is really one that we've put a lot of time into trying to figure out how to optimize because you can eat a bunch of time and a bunch of tokens doing a lot of parallelization and small tasks. We have more recently started to go back into much larger tasks and then accepted some level of cleanup at the end because basically if you try to break it down into these bite-sized pieces, it just frankly takes so much time and energy to get through, not energy, just time to get through. You know, like the accuracy didn't seem that much worth the amount of time and energy. So once again, I just keep saying energy. This is the problem with making videos when you haven't eaten today, really. So what it's going to do is it's basically a massive for loop really in many ways where it's going to try to implement. It's then going to run all the tests. It's going to still have a bunch of fails. It's then going to keep implementing, right? And it's being told, and we probably have the prompts here in a second. That's being told basically that the tests are the source of truth, right? So you have to treat the tests as the source of truth. You cannot weaken the test in any way. Now, at times it will do that. And so that's also where it goes back to part of the deterministic checks, or sometimes, for example, like making sure that none of the test code was changed in a loop or something like that. Okay, so here are the last sort of deterministic checks, and these are super critical. One, run your policy checks. This is your policy as code concept. If you haven't heard me talk about it, it's basically a massive linting system. So I'm a big believer that in the world of AI, you have rules, but those are inherently like non-deterministic in many ways. And so what we have the opportunity to now is basically codify every possible architecture, rule, decision, anything from where and how you can use raw CSS to what can be imported where, etc. And so basically you'd be stunned if you codified all of your architecture and PR things like a human would catch. If you put that into a script and then run that at the end of AI, how much it catches in terms of these little things that leak into the code base. And then the second is making sure that you actually run your standard lins, and those are important too. Great. And then after that all passes, you go at run and run your whole test case suite. Straightforward. And then at the end, we have the pipeline score itself by producing all of the receipts, right? So this is all the metrics and judging on what it worked, right? So if we go back and we look, you can see, so you have your greens, this is a refactor loop. You have your policy gate, which also would have a refactor loop. If this fails, this goes back and kicks into these. You have your full suite, and then you have your settings review, verify, and ledger. This, I believe, is unique to this because we have basically a set of reviews specifically designed around some of the issues that we've had in settings, which I can try to see if I will build settings prompt. Yeah, so what this is, and worth calling out, this is basically a bunch of issues that we've had in the past that basically we know you have to double check for. And it just goes back to you really have to use extra steps as safeguards. But once again, I know that goes completely in the face of what I was saying earlier in terms of the ability to try to minimize pipelines. All right, that's pretty much it. That's the pipeline, right? Yeah, this is a pipeline we use almost on a daily basis. It's super useful. Granted, the world's changing so fast that within a week it might be completely different, and I'll make an updated video, but this is what we use all the time when we're doing development in our settings areas. All right, couple other announcements. If you are still here and watching me, we have possibly a newsletter coming out in the next week that we're going to start doing. I'm going to start doing some links in the descriptions. I'm in the process still. I know I'm behind, but I have a 2-year-old at home of trying to get all this up into GitHub. Obviously, I think one of the areas of feedback for this is going to be like, hey, can you get this example up in GitHub? I'm just trying to clean it up in a way that is actually helpful to people. If you don't mind liking and subscribing to the channel, it goes a long ways. Otherwise, we will talk soon. See ya. Bye.